Welcome to International Definition. My name is Kenneth Freelain, and I'm going to be your host for today's edition of International Definition. Today on International Definition, we're going to feature the engineering tribute to the Presidential Inauguration of January 20th, 2013. Today, we're going to receive some information about the North American Water and Power Alliance. The North American Water and Power Alliance was conceived in the 1950s by the United States Army Corps of Engineers. Certain projects were called great projects, and one of the great projects involved the development of more water resources for the United States. The planners envisioned the diversion of water resources from some rivers in Alaska south through Canada by way of the Rocky Mountain Trench and other routes to the United States. And the entire project would involve 369 smaller and separate construction projects. The water would enter the United States through northern Montana. There, the water would be diverted to the headwaters of rivers like the Colorado River and others. The water would generate hydroelectric power as it passed through dams. The water supply would double the total amount of fresh water available to the lower 48 states, with its major focus being on the western states. This would solve the water shortage problems of the West for the foreseeable future. The amount of water available would in fact be so great that some water would be left over for use by Mexico by way of the Colorado River. By the way, today, the Colorado River is significantly depleted as it enters Mexico. The United States Army Corps of Engineers has studied this project in the late 1950s and in the early 1960s. This project was very close to realization. Washington State Senator Scoop Jackson was a significant sponsor. Senator Jackson was a person who believed in this project. The project was opposed by public sentiment in Canada. Recently, there has been a resurgence in the effort to implement NAWAPA, the North American Water and Power Alliance, as a result of the activities of Lyndon LaRouche and his LaRouche Pact. Now, let's watch a video which will provide us with some additional information about this proposed engineering project.
NAWAPA 21, an updated and expanded version of the 1964 proposal, seeks to create a continental system of water regulation that can redistribute wasted runoff waters of northern Canada and Alaska to make the Great American Desert bloom. It would turn would-be floodwaters in one area into the means for fighting drought in another, all through the construction of a massive infrastructural network which can direct these flows and provide a scientific analysis of their best use. The specific design arose out of the consideration of a unified management system which incorporates the topographical, geological, and hydrological characteristics of the North American continent, harnessing the abundant northern precipitation caused by the interaction of the Pacific Ocean weather patterns and mountain topography. The easterly migration of moist air evaporated from the Pacific Ocean contributes to very heavy precipitation along the cold, higher elevations of the Alaskan and British Columbian coasts, and also extends further down to the coastal mountains of Oregon. These regions receive the major portion of their annual moisture during the winter season, while the inverse is true for interior regions. When high-pressure ridges form near the west coast, even more water is diverted to Canada and Alaska, contributing to droughts in the west and underscoring the need for continental-scale water management. With a virtually constant input of solar energy to drive the ocean evaporation, a constantly replenishable water source is available if we apply our creative powers to harness it. NAWAPA 21 seeks to modify and redirect the awesome hydrological resources of the Pacific Ocean weather cycle through the continent's interior, extending the time the fresh water interacts with vegetation, stream and ground flow, and industrial processes before returning to the ocean. It is estimated that 40% of precipitation over continents returns directly as runoff or groundwater discharge to oceans, while the remaining 60% re-evaporates and falls back onto land, recycling itself an average of 2.7 times before returning to the ocean. In building NAWAPA 21, water which was once runoff will be used not once, but multiple times as it recycles as rainfall across the continent before exiting the system. The concept of NAWAPA 21 takes into account the anomalously high runoff in the north, totaling approximately 1,300 million acre-feet of water per year by conservative estimates, along with the fact of the very sparse water resources available in areas such as the southwest United States, where runoff is only about 32 million acre-feet per year. Of the total river basins in Alaska, British Columbia, and Yukon, the NAWAPA 21 catchment area encompasses rivers which have an annual runoff of 630 million acre-feet per year. Of this, the NAWAPA 21 collection system plans to redirect 22%, or 138 million acre-feet per year, for hydropower generation and for the distribution of water to the southwest United States and northern Mexico. The remaining 78% will flow in its normal direction. This 138 million acre-feet per year of water, used to upgrade the potential of these lands, would thus be about 11% of the excess water which is currently flowing, practically unused, into the ocean in Alaska, British Columbia, and Yukon. The original 1964 proposal increases the total Mackenzie Basin contribution to about 20%, providing 40 million acre-feet of water per year for agriculture in the prairie provinces and a barge canal from the Peace River to Lake Superior. In Utah, the water flow will branch in two directions. The first branch heads into southern Nevada and then branches west into California's Panamint Valley and south, paralleling the Colorado River to irrigate southern California, western Arizona, and northern Mexico. The second branch flows into eastern and southeastern Utah, linking up with Lake Powell's distribution system. Part of the flow could be used to supplement the Colorado River and increase the power capacity of the Hoover Dam. Continuing into Arizona, 11 reservoirs are created, including what will become Lake Navajo, 30 miles from Flagstaff, which, at over 3 times the size of Lake Mead, will be the largest reservoir on the United States side of the project. Canals branch throughout the state, providing water where irrigation is needed, with one branch creating 5 reservoirs west of Phoenix and continuing into Sonora, and the other creating 3 reservoirs as it enters into New Mexico. The New Mexico distribution brings substantial flows to the Pecos and Rio Grande regions via 3 branches down into northern Mexico and Texas, and creates 2 major reservoirs in New Mexico, one the size of Lake Mead, before pumping water north to Colorado. In total, 32 reservoirs will be created throughout the Southwest, with a total storage capacity of 233 million acre-feet of water. As currently designed, the system would deliver 52 million acre-feet per year for distribution through the Southwest, enough water to cover deficits in the Colorado and Rio Grande basin reservoirs and delivery systems, and will add enough water to irrigate 19 million acres of land, twice the current amount. It would deliver 20 million acre-feet per year to northern Mexico, irrigating up to 5 million acres. By way of the Great Lakes Seaway Canal, 19.6 million acre-feet of water would be delivered to Alberta, Saskatchewan, and Manitoba, enough water to irrigate up to 9 million acres of land, or supply water for industrial and petrochemical developments in the region. The Dakota Canal would deliver 11 million acre-feet per year to North and South Dakota, irrigating approximately 3 million acres. Being built along a continental divide, the canal could serve as a water redirection system, solving the annual flooding problem in the Grand Forks, Fargo-Moorhead areas of Minnesota and North Dakota. This Great Lakes Seaway system, stretching from Vancouver, British Columbia to Lake Superior, along with a branch to the Hudson Bay, as well as a canal from James Bay to Georgian Bay, will open up a vast amount of resource potential for Canadian development and export, creating an industrial and water transport corridor throughout southern Canada akin to the Mississippi River Barge Corridor. By constructing the system of storage, flood control, and water delivery, the utilization of the total topographical potential which the project intersects will produce a surplus of power, over the 36 gigawatts of electrical power required for pumping within the project. Most notable will be an annual surplus of 32 gigawatts in British Columbia, a greater than 100% increase of its current power capacity. The original 1964 proposal estimates that building NAWAPA would require 100,000 workers employed for 30 years and would create some 4 million jobs through direct and indirect employment. An updated estimate, based on NAWAPA 21, needs to be produced. It must take into account the new additions to the project that would augment water flow in certain basins, the needed rebuilding of today's decrepit basic infrastructure and manufacturing facilities, and the new technologies that were not included in the original plan, such as nuclear reactors, satellite imaging, and large-diameter tunnel boring machines. No part of the original design is exempt from alteration if a new or more detailed analysis finds that a modification is either more appropriate for today's needs or more scientifically efficient. Updates to NAWAPA 21 will include all programs which can be naturally incorporated into the continental system, following the topographical, geological, and hydrological characteristics as a whole, irrespective of local issues. Along with water regulation extensions added to the original NAWAPA project, there are further important changes that will be required. For the lower 48 states, a major expansion to the current rail grid, both with respect to routes and equipment, is needed. High-capacity lines, as well as a number of rail cars, will need to be manufactured before the efficient transport of construction materials and machinery, requisite for NAWAPA 21, can be executed. The Canadian Pacific will need additional routes to lower British Columbia, as well as a major investment to complete the Alaskan-Canadian connection system, estimated at 2,000 miles, for 2 new routes. These routes can be adjusted to meet the needs of NAWAPA 21. A planned Central North American trade corridor, stretching from Mexico through Texas, North Dakota, and on to Alaska, linking with the proposed Bering Strait Tunnel, can similarly be adjusted to meet the needs and reap the benefits of NAWAPA 21. As exemplified by the construction of the Transcontinental Railroad in the 19th century, such transportation corridors will serve as important catalysts for new city building in the underpopulated western and northern regions of the United States and Canada. The roads needed for the rail construction and the subsequently installed rail lines will create transport corridors from the states of Washington and North Dakota directly through British Columbia, Saskatchewan, and Alberta to Alaska and Yukon. These corridors will not only provide efficient construction and maintenance of the NAWAPA system components, but, along with the barge canals planned in the original design, will open up access to new areas of northern Canada and Alaska for scientific analysis, resource prospecting, mining, and processing, in addition to supporting already existing mineral and energy resources in the area. This is not mere resource extraction. It will signify the long overdue development of the vast territories of Canada and Alaska. The infrastructure needed for the efficient construction of NAWAPA 21 will simultaneously aid the United States and Canada in establishing a presence in what is becoming the next great frontier for human development, the Arctic. The harsh conditions associated with intensive industrial operations near the Arctic will demand great breakthroughs in engineering techniques and will serve as a springboard and testing ground for various space technologies involved in lunar industrialization, as shown by the design for the city of Umka, currently proposed for the Russian Arctic, based on the life support designs of the International Space Station. NAWAPA 21, during its 20 to 30 year construction cycle, will transform and advance the physical economies of the United States, Canada, and Mexico, and will be a virtual laboratory for the development of new industrial technologies, new applications of the geotechnical sciences, and new methods of large-scale biospheric engineering. The detailed plans for the construction of NAWAPA 21, along with the details of how NAWAPA will restore the public credit of the United States, are contained in the recently published LaRouche-Pac Special Report, NAWAPA 21. A PDF of the report is available online at larouchepac.com/NAWAPA21. To order, call 1-800-929-7566. Further video material discussing the details of NAWAPA 21 are also available at larouchepac.com/NAWAPA21.
Following the release of the full NAWAPA 21 animated overview, we now present extensions to the project, which further underscore the continent-wide water management approach proposed by NAWAPA 21. Here we present the Oregon-California extension originally designed by Hal Cooper in Washington State. But first, let's take a look at the continent's current water cycle. Easterly migration of moist air evaporated from the Pacific Ocean contributes to very heavy precipitation along the cold, higher elevations of the Alaskan and British Columbian coasts, extending further down to the coastal mountains of Oregon. These regions receive the major portion of their annual moisture during the winter season, while the inverse is true for the interior regions. When high-pressure ridges form near the west coast, even more water is diverted to Canada and Alaska, while at the same time contributing to droughts in the west, underscoring the need for continental-scale water management. With a virtually constant input of solar energy to drive the ocean evaporation, a constantly replenishable water source is available. Of the approximately 2,200 million acre-feet of annual precipitation in Alaska, Yukon, and British Columbia, 1,300 million acre-feet is runoff. While the majority of this runoff is unused, the mere 32 million acre-feet of mean annual discharge of the main river basins of the U.S. Southwest is almost 100% in use. Of the total river basins in Alaska, British Columbia, and the Yukon, the NAWAPA 21 catchment area encompasses rivers which have an annual runoff of 630 million acre-feet a year. Of this, the NAWAPA 21 collection systems plan to redirect 22%, or 138 million acre-feet, for hydropower generation and the distribution of water to the southwest United States and northern Mexico. This 138 million acre-feet of water would thus be about 11% of the runoff of Alaska, British Columbia, and the Yukon. An estimated 49 million acre-feet is to be used for power generation at the pumping stations in British Columbia and Idaho. With a slight modification to the original plan's power requirements for pump lifting, the NAWAPA 21 plan could include an extension, originally designed by engineer Hal Cooper of Cooper Consulting Company, the Oregon-California extension. By either increasing the collection of that total runoff by 1%, or by utilizing nuclear power instead of hydropower generation at these locations, 15 million acre-feet could be freed up and added to the 60 million acre-feet which is pumped into the Rocky Mountain Trench each year, and then be used to feed the Oregon-California extension via the Columbia River. Here is a detailed tour of the proposal. The additional 10 to 15 million acre-feet flowing down the Columbia River will increase the hydroelectric capacity of the Grand Coulee Dam and other smaller dams under the Bonneville Power Administration. When these 10 to 15 million acre-feet reach the Dalles Dam, they will be pumped up a series of staged reservoirs on the Deschutes River, bringing the waters up onto the Columbia Basin, before then being taken by canal over to a large storage facility at the Prineville Reservoir near Prineville, Oregon. Taken south by canal, the water will be brought to a distribution reservoir at Silver Lake, southeast of Bend, Oregon. These 10 to 15 million acre-feet of fresh water can then be diverted west through a 20-mile tunnel under the Cascades to the headwaters of the Klamath River, refilling its depleted waters and reviving its fishing industry all the way out to the Pacific. From Silver Lake, water can also be taken by canal east across the Oregon deserts, replenishing and creating anew several reservoirs such as Harney Lake and the previous dry Turnbull Lake near Burns Junction, before then heading south down the Owyhee River to the Snake River in West Idaho to restore needed groundwaters and other waters all the way out to the Tri-Cities area of Washington State. From Silver Lake to the south, water will flow by canal into Goose Lake and then into both the Eagle Reservoir system and down the Pitt River into the Shasta Lake system north of Redding, refurbishing the existing water supplies of Northern California for fishing, farming, and other needs of the population. The most extended route of the project takes waters from Goose Lake through a 12-mile tunnel under the Warner Mountains, refilling the currently dry lake beds near Cedarville, California. These waters are then taken by canal into Pyramid Lake, northeast of Reno, Nevada, before flowing further south into Walker Lake. A long tunnel will then take the water up into Mono Lake on the eastern side of the Sierra Nevada mountains, where water can be transferred up into Lake Crowley, a new storage reservoir at the headwaters of the Owens River. With renewed waters flowing down the Owens River, Lake Owens and the previous agriculture in the Owens Valley will be restored. On the last leg of the project, sufficient water will be brought by canal to replenish Lake Cohen and Lake Rosamond northeast of Los Angeles. Here, an additional canal can be constructed to connect the NAWAPA 21 waters brought into Death Valley. With this Oregon-California extension to NAWAPA 21, a significant addition to the greening of the Great American Desert and the creation of additional rains across this area will be made, not to mention the large increase in the livelihood of the people of this region.
I'm glad that you were able to join us for today's edition of International Definition. Today on International Definition, we examine the North American Water and Power Alliance, also known as NAWAPA. We did this as a part of the engineering tribute to the Presidential Inauguration of January 20th, 2013. And now, until our next broadcast, I'm your host, Kenneth Freelain, thanking you for joining us today.